Yes. Yes. Right. Right. Okay. Yes. Yes. Right. Okay. Right. Okay. Uh Now time is 6 7. So we'll start exactly at 6:15. Right. Give me 5 more minutes. We'll start at 6:15. So you can go and you can wash your face and come. If not, you can drink, you can eat something and come at 6:15. Today plan, I will tell you the upcoming our fusion class plan. Everything I will tell you. Okay. We'll start at 6:15. Right. Now I think I shared that today we are starting from vectors. So our revision class, we are starting from vectors. I shared vector short note PDF. And already I told you that now if you are planning to join today's session, I told you to take a printout. So then you can write on everything on that PDF. Right. Again, I will share that PDF in both the groups. Right. I will share in that revision group and I will share in the main group as well. Better if you have taken what printouts, then you can write down everything on that PDF. Then we can revise all the points in vectors and we can go on. I'll share it. Right. Okay. I shared the PDF in all the groups. You can go and you can refer them. Okay. Right. 6:15 time. Now, can someone reply whether you can hear me speaking? Quickly reply. Quickly reply someone whether you can hear me speaking. Quickly. So you want to reply to the now there are two accounts. You know that now. I enroll to this Zoom in two accounts. One is Sir account, other one is Suleiman Nawaz. I stream this video and voice through Suleiman Nawaz, but I see the chat messages through that Sir account. So therefore, reply if you have any doubts or anything, reply to Sir account, right? Okay. Now this is the plan. Now now in here there are two types of students. One type is students who are planning to join for a revision class. If not, students who have paid for revision classes, that is one category. And also there are some 26 A level students also in with the intention of covering the miss sections, right? Now since we are discussing, since we are revising unit 2 vectors, therefore both of can understand today's session. Okay, but mainly now this is for mainly 25 revision class, but 26 students also can understand everything. You can revise it, but mainly today's session is for 25 revision class students. 25 revision class students. Now I will tell you, now I will talk a little bit now, brief it. Now you might have seen my recordings, you might know about me, the way I teach you everything, you have an understanding, right? I'm not going to say anything about me. After teaching for 24 batch, 24 theory batch, then I just checked how the way they perform the 24 A level exams. Then most of them, now my crowd is very small crowd, right? I don't have a big student base, but 24 best students, the way they perform the exam really made me to think twice to conduct revision classes. Okay. Now uh right. Okay, now okay, the board is blurred, ne? The connection issues. Right. So wait, give me a few minutes, okay? Give me a few minutes. Now I'm not at Colombo. Give me a few minutes. Give me a few minutes. Right. I think now everything is fine. Right. Okay. So I told you, as I already told you, now after 24 batch finishes, then I decided to conduct a revision class because most of students have performed very well in their exam. So then I thought that to conduct a revision class for students who did 24 A level exam and who could not do the exam better, to give a support. Only I decided to do a revision class. Okay. So then the plan is very simple. The plan is very simple, right? Plan is very simple. The plan is very simple. Now what are we going to do is now, right? Look here. Now time is already 6:30, 6:25. It's okay. Now, as I already shared in the group, I thought of do revision because most of you, even you covered all the theory in the theory classes, sometimes you can't remember everything, right? Some of you might didn't cover the some sections, right? So you don't know some theories. So then, addition to that, some of you know the theories, but you didn't try enough questions, right? You need a more question practice. So then based on all these points, now I thought of do this revision like this. Now revising is important. Even you learn the theories. So when we revise briefly, right? For an example, vectors lesson, if I revise briefly, definitely that's gonna be effective for you. Even you covered the vectors theory, even you know vectors theory, but revising vectors theory again is really beneficial for everyone. Okay. So then by revising that, what we do now, for an example, now I thought of do like this. I thought of do unit 2, unit 3, and unit 4 parallelly, right? So we are starting unit 2, we are starting from vectors. Then unit 3, we are starting from optics, refraction through plane surface. And unit 4, we are starting from expansion, solid expansion. It doesn't matter, even you don't know the previous any theory before, even you didn't learn these sections before, that's completely all right. If you come from the beginning, you will be able to catch everything, right? So every week I will send the plan. Right now my plan is today we are covering vector full revision. Then next week unit 3 optics. Then unit 4 solid expansion, right? Then after revising those three sections in those three units, what are we going to do is we are going to revise a paper on Saturday. So only from vectors, then solid expansion, then optical instruments, then optics, refraction through plane surface. We are going to prepare a paper, MCQs and essays. Then what we do, we'll write a paper. So then we'll provide the marks and we'll evaluate. Likewise, what we do now next week, then we are starting linear motion. Unit 2 linear motion. Let's say unit 3 lenses for an example. Then unit 4 we are starting thermodynamics or something. Then what will happen every week? Week by week what will happen? The amount of theory that you covered in the revision class increases. In that case, we can do little by little a good full paper. That's the plan. That's the plan. Okay, right now. Raise your hands. Everything is very clear so far. Everything is very clear. Raise your hands quickly. Everything is fine. Everything is fine, and everything is fine. Okay, right. Okay, now we'll start vectors. I will share now. Last week for 26 batch cover up, I started from dimensions. 26 cover up class. Last Sunday, if I can remember, I revised unit 1 dimensions. Unit 1 dimensions, I revised. So I will upload this quick revision in dimensions in 25 revision that class. So what I do, I will upload this unit 1 dimension quick revision video. I will upload in the 25 revision class. Right after today's session finishes, what you do, you revise, watch this recording also. Right? Then if you don't know dimensions part, you can revise everything. Now we'll go to this vector section, right? Okay, we'll start. Now time is exactly 6:30. We plan to start at 6 o'clock, but it's fine. Now time is 6:30. Now starting from unit 2, vectors, a full revision, right? Full revision. Okay. Now, if if you have that PDF as printed format, better. I told you take a print out, so then you can write everything on that PDF. Now, already we know that refer that dimensions recording also. Now we know physical quantities we can divide into 2 categories. Physical quantities means, if I brief it, whatever the change happening in the universe, if we can measure directly or indirectly, that is what we identified as physical quantity, right? Then for an example, we know physical quantities, example what? Mass, length, volume, time, acceleration, velocity, they all can be categorized to physical quantities. Then physical quantities, we can divide into 2 categories, right? One is scalar, other one is vector. One is scalar, other one is vector. Okay. Physical quantities, we can divide into 2 categories. One is scalar, other one is vector. Scalar, scalars. Other one is vectors. Now, why we should divide? Why are we dividing physical quantities into 2 categories, scalars and vectors? The reason is, some physical quantities we are not able to describe only with the magnitude. There are some physical quantities, in order to describe that physical quantity, we should define magnitude and direction. But there are some physical quantities, if we only mention the magnitude, that is sufficient to describe that physical quantity. For an example, let's consider mass. Mass measured in kilograms. Let's say now, if you want to say someone bring dal of 5 kilograms, then that person is able to understand. When you say bring 5 kilogram dal, then that guy understands. Right, I want to bring 5 kilogram dal. Right, only mentioning magnitude is sufficient to describe some physical quantities. For an example, mass, then volume, then density. Volume means, I give a bottle to someone and I tell that, please fill 5 milliliter of water. Please fill 5 milliliter of water. Then I am describing volume, physical quantity. If I'm mentioning magnitude, 5 milliliter, 5. Only magnitude is sufficient to describe a certain physical quantity. Means that is what we identify as scalars. Scalars. So then only magnitude. Scalars only has magnitude. Right? Only magnitude. Now give some examples for scalars. One example is, mass. Examples. Other one is volume. If not distance, if not time, 5 seconds, right? Mass, volume, time, distance. Then we can tell energy. They all are scalars. Then what is vector? Vector means, we know that some physical quantities require direction also in addition to magnitude to describe the physical quantity. For an example, we all know the most popular vector is force. Okay. Now, if you are describing the force, we know, if you are describing the force, let's say now you are telling, now you want to say there's an object. So there's an object. Let's say now Now you should move this object to right side direction. You want to move this object right side direction. Then you know the force you should apply on this object is 5 Newton. You know magnitude is 5 Newton. Now what you do, now there is a person nearby the object. You ask that person, you tell him, please apply 5 Newton force. You should, you are planning to move this object to right side. There's a person nearby the object. You instruct him, please apply 5 Newton force. But what happens? This guy is applying 5 Newton force on the object upward direction. Because you didn't mention any direction. You just told apply 5 Newton force on the object. That guy applied 5 Newton force, but in upward direction. You wanted to move right side. That means you wanted to apply 5 Newton right side direction. But as you only mentioned the magnitude, it misleaded that guy to move the object upwards. So therefore, some physical quantities require magnitude and direction both to describe that physical quantity properly. Such physical quantities we name as vectors. Such physical quantities we name as vectors. Then vectors has magnitude and direction both. Both magnitude and direction. Both magnitude and direction. Examples. We know examples. Force is a vector. Force, linear momentum, if not velocity, acceleration, all those are vectors. Linear momentum. Then let's say velocity. Then acceleration. They all are vectors. So you understood physical quantity, vector, scalar. Scalars have magnitude only. Vectors has magnitude and direction both. Magnitude and direction both. That idea is done. In this lesson, what are we doing? In this lesson, we talk about vectors. We talk about vectors, right? Now then, vector notation. Vector notation. How do we represent the vector? Right? Next one is vector notation and graphical representation. Vector notation, graphical representation, graphical representation. Now, vector, any vector, force, it can be velocity, it can be acceleration, we represent using a straight line, right? Right? We represent any vector using a straight line. But you must understand length of the line proportional to the magnitude. Length of the line proportional to the magnitude of the vector. Proportional to the magnitude of the vector. And in order to represent the direction, since vectors has magnitude and direction, length of that line proportional to the magnitude, and arrow. We are using an arrow to represent the direction. Arrow to represent the direction. Right? Arrow to represent the direction. So, for an example, if you write like this, this is what we call as a vector. This is the vector graphical representation. Graphical representation. So then, how do we notate this vector? Right? Normally, we can notate vectors in two different ways. By using one simple letter, we can notate a vector. Notating means we are giving a name for that vector. We are giving a name for that vector. Right? So we can use a simple letter. When you write a simple letter and when you put this line below that letter, this shows about vector A. Right? This is one type of vector notation. If not, what we can do, we can use two capital letters. If you're using simple letters, you should use only one simple letter to represent the vector. Your name, your name for this vector as vector A. If not, what you can do, you can give a name using two capital letters. This point is a capital A, this point is capital B, then arrowhead is from A to B, arrowhead is from A to B, therefore you can say this vector as vector AB. Vector AB right direction. You understand? Right? So then vector notation means we can use one simple letter. Below there is a small line. If not, we can use two capital letters, AB above that AB letter, there's an arrow. Simple letter means one small line. Capital letters means an arrow above AB. Okay, that is the vector notation. Now, for an example, now you also write down in that PDF that empty space. You should write down these. Okay. Now, for an example, let's say now you want to represent. For an example, you want to represent a vector. Let's say 10 Newton force. Now there's an object. So there's an object. Example. There's an object. Let's say 10 Newton force. 10 Newton force acting on the object horizontal right direction. 10 Newton force acting on the object horizontally right side direction. Now, I ask you to represent this vector graphically. Then what you should do, you should draw a graphical representation. GR, graphical representation. Then what you should do, you should draw a horizontal line because vector is horizontal right side direction. But remember, length of this line should be proportional to the magnitude of the vector. Then you want to go with the scale. How do you say? You can define 1 centimeter represents, let's say, 1 Newton force. Length of 1 centimeter represents magnitude of 1 Newton. Then how are I going to represent this 10 Newton? How are I going to represent this 10 Newton? Then if where 1 centimeter is equivalent to 1 Newton means, if I want to represent 10 Newton, I should draw a line segment of length 10 centimeter. You should take your ruler and you should exactly measure the length 10 centimeter. Then you put the arrow. Then this says about what? Then this says about graphical representation of 10 Newton. But definitely in exam essay questions only, they can ask these type of questions. In essay question, if they ask you to represent this vector graphically, you should mention the scale. You should mention the scale. If not, they don't understand one length, 1 centimeter equivalent to what, how much magnitude, they don't know. Now, another example, let's say now there is a, velocity. Velocity is a vector. Let's say now you want to represent a velocity. This angle is, let's say, 30 degree. This velocity is 5 ms minus 1. If you want to represent this vector graphically, what you should do, you should draw a line segment. But remember, its length must be proportional to the magnitude of the vector. Then you can say 1 centimeter length equivalent to 1 ms minus 1. Then in order to represent this magnitude, your length should be 5 centimeters. 5 centimeter length, arrow, you should take what? You should take a what? Protractor, and you should measure this angle exactly 30. You should use a ruler. You should measure the length of the segment according to the scale, and you should use a protractor to mark this angle 30 properly. So this is vector graphical representation, how we represent vector graphically. Then vector notation, you understood. Okay, you understood. So normally I can tell now this vector A, if not vector capital AB, vector capital CD, vector capital EF, you can use any letters. Now that is the vector representation. Okay, then that is also done. Then what are we doing? Now, when you consider vectors, let's say now if they have given two vectors, and if they mention two vectors are equal, then there should be some conditions satisfied by those two vectors. If they have given two vectors, look here. Now you keep your focus and write down everything. Now if they have given two vectors, equality of vectors. Equality of vectors. Now they have given two vectors, vector A and vector B, right? If vector A equals to vector B, remember, first condition is magnitude of vector A and magnitude of vector B must be same. Okay, magnitude of vector A, magnitude of vector B must be same. That is the first condition. Second condition, remember, direction of vector A and direction of vector B must be same. Third condition, vector A and vector B both homogeneous. MDH, magnitude must be same, If vector A and vector B are equal, magnitude must be same, direction must be same. You understood these two ideas, you can understand what does it mean by these two vectors should be homogeneous. For an example, let's say this vector A is a velocity. Vector A is a velocity. Let's say this vector B is displacement. If not vector A is velocity, vector B is force. Then do you think vector A and vector B are homogeneous? No, they are heterogeneous. This is a velocity vector. If this is a force vector, they are heterogeneous, not homogeneous. Then they can't be equal. How 5 Newton force equal to 5 ms minus 1? Can you write down 5 Newton force equal to 5 ms minus 1? We can't write down, right? Even they, now let's say now there are two vectors. Okay, there are two vectors. Now there are two vectors, right? Example, now example, you write all these points on the paper, right? Let's say now there are two vectors, phi ms minus 1, angle is 30, right? There is another vector that is phi Newton, angle is 30. So you understood when you consider these two vectors. I name this vector as vector simple A, this vector is vector simple B, right? Now, if in the exam, if they ask whether this vector A and vector B are equal or not, you want to check 4 conditions. First condition is magnitude. We know magnitude in vector A also phi, magnitude in vector B also phi. Therefore, magnitude wise, they are equal. Direction wise, yes. This direction 30-degree angle. Vector B also in this direction 30-degree angle. Direction wise also they are equal. They are equal. They are equal. But do they homogeneous? Do they homogeneous? Homogeneous means same type of vector. This is a velocity vector. This is a force vector. So therefore they are not homogeneous. They are heterogeneous. And therefore this condition fails. This condition fails. Right? The last characteristic is parallel. Yes, these two vectors parallel. See, these two vectors are parallel vectors. Last condition also satisfied by them, but unfortunately, they are not homogeneous. Therefore, we can't tell these two vectors are equal. Okay. Summary is very clear. If in order to consider two vectors are equal, they are magnitude, direction, homogeneous, and parallel. If all 4 conditions are satisfied only, we can consider those two vectors are equal, right? For an example, let's say, another example, let's say, now, so this is 5 Newton. This is 5 Newton. Raise your hands, how many of you say these two vectors are equal hands? Raise your hands, how many of you say these two vectors are equal hands? These two vectors are equal hands up. How many of you see? They are not equal. This vector A, vector B are not equal hands up. They are not equal. They are not equal hands up. They are not equal hands up. So you understand that they are not equal, right? They are not equal. That is the idea. Okay. So then you understood the equality of vectors. Now you should understand vector multiplication, right? Vector multiplication, right? Now, next idea, vector multiplication. Multiplication. Now we can talk vector multiplication in 2 different scenarios. Vector multiplication we can discuss in 2 different scenarios. Now what will happen? Just take scale multiplication. You are very familiar. O levels, grade 9, 10 mathematics. What you do many times you you tried scale multiplication. For an example, scale multiplication means if there is a scale, give me a value. Let's say 5. Now you know how when you multiply 5 by 2, the answer is 10. Answer is 10. Right? Let's say now 10. 10 by if you multiply by a scalar, 10 if you multiply by a scalar, 3. 10 into 3 means 30. 10 into 3 means 30. Right? But vector multiplication is something different. Vector multiplication is something different. We can discuss vector multiplication in 2 different ways. Okay. When you multiply a vector by negative sign, right? First one is you are multiplying a vector by negative sign. by negative sign. Second one is you are multiplying a vector by a scalar. Second one is you are multiplying a vector by scalar. Right, scalar. Then what will happen? Okay. Now, example, let's take. Now there is a vector. So there's a vector. This vector is, I will name this vector as vector simple A. And if not, I will tell this point is point capital A, this point is point capital B. I can tell this vector as vector AB. Okay. This vector is vector AB. Right. This vector is vector simple A, if not vector capital AB. Now what will happen? What will happen when you multiply vector AB by a negative sign? Remember, if you multiply vector AB by negative sign, what will happen? What will happen? This vector's magnitude remains same. When you multiply a vector by negative sign, its magnitude remains same, but remember direction changes. Remember direction changes. So magnitude same, but remember direction changes. But remember direction changes. Direction becomes opposite. Direction becomes opposite. Opposite. If I explain further, now you write down these things in those spaces, right? Now this is vector AB. So when you multiply vector AB by minus, okay, now that is equal to vector BA. That is equal to vector BA. Why? Why? Look here. Look here. This is your vector AB. This angle is, let's say this angle is theta. Vector AB. When you multiply this vector by minus, right, that is equal to vector BA. All the direction changes, right? Now early direction is in upward direction. Now direction is down direction, vector BA, right? BA vector. So remember, therefore negative vector AB means vector BA. Am I correct? Negative vector AB means vector BA. When you multiply vector BA by minus, what you get? When you multiply vector BA by minus, that is equal to, when you multiply vector BA by minus, that is equal to vector AB. So simple, idea simple. If there is a vector, when you multiply by minus, only magnitude, only direction changes. Magnitude is same. Okay. Direction only changing. That is important point. Next one is multiplication of a vector by scalar. Remember, when you multiply a vector by scalar, direction remains same, but magnitude changes. Write all this, huh? Right? In this case, here, direction same. Direction same, but magnitude changes. Magnitude changes. For an example, I will tell that vector simple A means 5 Newton force, right side direction. Vector simple A means 5 Newton force, right side direction. When you multiply vector simple A by 5, when you multiply vector simple A by 5, now, when you multiply by 5, now direction is same as right side direction. But now new vector's magnitude is 5 times greater than initial vector. What is the magnitude of initial vector is 5 Newton. When you multiply by a scale of 5, now magnitude of new vector is 25 Newton. 25 Newton. Right? Now this is vector B. This is vector B. So when you multiply a vector by 5, magnitude changes, So therefore, it forms a new vector. Okay, that's the idea. Now, always understand vector means, remember, vector has magnitude and direction. Vector has magnitude and direction. When magnitude changes, when direction changes, remember that vector changes. Right? For an example, earlier 500 force acting upwards. When you multiply by minus, now 5 Newton acts downwards. That means that is a new vector. Right? If you multiply a vector by scalar, then also vector changes. Right? Earlier magnitude is, let's say, 1. If you multiply by 5 scalar, now magnitude is 5. Right? That is the basic idea. Now everything is very clear so far, hands up. Now revising, okay? Now this is recalling. If you understood everything, raise your hands. If you understand everything, raise your hands. Quickly. Quickly raise your hands. Raise your hands quickly if you understood everything. Okay. Right. Okay. So then you know resultant vector. So then we'll talk about resultant vector. Right. Now I erase this. Now we'll talk about resultant vector. Now resultant vector means, you know, now I can explain like this. I can explain like this. Now resultant vector. Resultant vector. Now, right, now you know the force. You know the force. Force is a vector. We know force is a vector. Just think there is a vehicle. There's a vehicle. There are many forces acting on the vehicle. Right? As in that PDF, let's say now there are many forces. Now, forces are vectors. Right? So now, you know, here there are many forces. Vector, force A. Now vector A means a force. Let's say 5 Newton, this direction. So then this is another vector, another force, 10 Newton. I name it as vector B. Another force, this is, let's say, 12 Newton downwards, vector C. Another force, that is 30 Newton, this direction, vector D. Right? Now, there are many vectors acting on a system. Then what is the result? When, because of these 4 forces acting on this car, what is the result that we obtain? The result is this car accelerates. For an example, the result is this car accelerates right side direction with a magnitude 5 ms minus 2. What is the result of applying these 4 vectors? The result is this car accelerates with 5 ms minus 2 right side direction. Okay, have a listen. Because of these 4 vectors, because of these 4 forces, the result is accelerates to right side direction with a magnitude 5. Now, how do we define resultant vector? The resultant means the single vector. Now here, because of these 4 vectors only, we obtain this result. What is resultant vector? In order to obtain same result, acceleration 5 ms minus to right side direction, the vector, the single vector you should provide on the car, that is what we call as resultant vector of these 4 vectors. Okay, that is the idea. Okay, now same car, but again, in order to obtain same result, that means acceleration phi m is minus 2, direction is right side direction. In order to obtain same result, the single vector that you should provide on the car, okay, the single vector that you should provide on the car, this is what we call as resultant vector of these 4 vectors, right? Whatever the result given by set of vectors, the single vector which gives the same result, that single vector we call as the resultant of those 4 vectors. That is the idea. So you know the resultant vector idea, right? So then you should know that what is this vector resolution. Vector resolution is very important to understand upcoming sections also. Vector resolution, you know that what we do basically in vector resolution, we basically divide a given vector into 2 components, right? Vector resolution. Here what we do, a given vector. Let's say now this vector is vector P. This vector is, the name of the vector is vector P. Vector simple P, vector P. Now what we do, if we are breaking a given vector into 2 perpendicular components, that is what we call as vector resolution. A given vector, if we are breaking into 2 components, that is what we call as vector resolution. Okay, but we should break this given vector into 2 perpendicular directions. This vector should be broken into 2 perpendicular directions. Most of the time, that is horizontal and vertical directions. That is mostly horizontal and vertical directions. Okay, right? We are breaking this vector into 2 vectors. This vector, we are breaking into 2 vectors. Those 2 vectors are perpendicular to each other. So let's say now you know this angle is theta. This angle is theta. Then remember, now I am breaking this vector into horizontal component and vertical component. So then, this is my horizontal component, carefully listen. And the vertical component will be this one. Always the component touches the angle. Always remember the component touches the angle cos. You don't ask why. This component is, now I am breaking this vector into 2 components. This one, this one. This horizontal component touches the angle. The component touches the angle is cos. So remember, you can write down this component magnitude as P cos theta. P cos theta. The component which is not touching the angle, that is sine. The component touches the angle cos, component not touches the angle sine. This one we can write down P sine theta. So simply, vector resolution means a given vector we are breaking into 2 perpendicular vectors. So remember, this vector equivalent to these 2 vectors. This vector equal to these 2 vectors. If not, I can say, using this resultant vector idea, resultant of these 2 vectors equal to this one. That is the idea. Now, sample question. I have given two sample questions. Sample question 1, sample question 2. I will give 2 minutes. Quickly resolve those vectors quickly. Once you finish resolved, raise your hands. Once you finish resolved, raise your hands. Once you resolved, raise your hands. Quickly. Finished? Now, SQ1. Right, SQ1. Sample question 1. Now, that is magnitude is not given. I think they didn't print it. Now take first vector magnitude as 5 Newton. Take first vector magnitude as 5 Newton. Second one is take 10 ms minus 1. First one 5 Newton. Second one 10 ms minus 1. Right? SQ first one. This angle is given as 30. This angle given as 30. Magnitude of this vector is 5 Newton. Quickly resolve this 5 Newton into two perpendicular components. One is vertical, other one is horizontal. Right? I told you, this is vertical component. This one is vertical component. This one is horizontal component. The component touches the angle cos. The component touches the angle cos. Therefore, we can write in 5 cos 30. So this component will be 5 cos 30. Now, you know, cos 30 means root 3 over 2. Cos 30 means, you know, 5 root 3 over 2. Right? So that means 2.5 root 3. Right? 2.5 root 3. You can simplify this later. Newtons. Then how do we find this component magnitude? The component touches the angle cos, the other one is sine. This one will be 5 sine 30. 5 sine 30. That means 5 into sine 30 means half. That means 2.5 Newton. Sample question 1. So let's do sample question 2 also. Sample question 2. Sample question 2. Now in here, sample question 2, what we can do now, second one is next one is 10 ms minus 1. This is 10 ms minus 1. 10 ms minus 1. This angle given as 60. Then if you convert into two perpendicular components, 10 ms minus 1, two perpendicular components, this is one component, this is the other one. Right? So then this component will be, the component touches the angle cos. Component touches the angle cos. Then this one will be 10 cos 60. 10 cos 60. This component will be, you know, 10 sine 60. Now, special case also there. Now, most of the time in MCQs, in questions, you want to resolve a given vector into two perpendicular components. Mostly, those two perpendicular components are horizontal and vertical. Normally, normal case, they give the inclined vector and you want to obtain horizontal and vertical components. You want to obtain horizontal and vertical components, normal case. Normally, they give the vector inclined, the vector to be resolved inclined. You want to convert to horizontal and vertical components. That is the normal case. But there is special case also. In special case, they give the vector to be resolved horizontal or vertical. You want to obtain their components in inclined directions. For an example, third one, just think. Third one, 15 Newton for an example. Third one, 15 Newton for an example. Now, third one, what you can do now, okay? Special case. Third one, what we can do now, the given vector is horizontal. Normally, vector to be resolved is inclined. The components are perpendicular, components are horizontal and vertical. Vertical, horizontal. But in special case, vector to be resolved, they give as horizontal or vertical. You want to obtain perpendicular components in inclined directions. Okay. Now this example, just this is 15 meters for an example, 15 meters. This angle is given as 30. This time you want to resolve this vector into two perpendicular directions. One is in this direction, other one is in this direction. Right? How you do that one? The same story. These two components have, and these two components are perpendicular. These two components are perpendicular. This one is how much? This one, you want to obtain these two values, these two component values. This component touches the angle 30. Therefore, 15 cos 30. This one will be 15 cos 30. 15 cos 30. This one will be 15 sin 30. 15 sin 30. This is the idea of vector resolution. Right? You know what is vector resolution? A given vector we break into two perpendicular vector components. Then you know how to find the magnitude of those two components, cos 30, sin 30. The component touches the angle is cos, the other one is sin. The other one is sin. Okay. That is the story. Okay. Then what? Then what? Then vector addition. Vector addition. Okay. Right. Now vector addition. Now we talked about equality of two vectors. If two vectors are equal, magnitude, direction, homogeneous, parallel. And vector multiplication. Vector multiplication means you know that we can multiply a vector by negative sign. If not, we can multiply by a scalar. When we multiply a vector by negative sign, only direction becomes opposite. Magnitude is remaining same. But when you multiply a vector by a scalar, direction same, but magnitude changes. Right now we are talking about vector addition, adding vectors. Remember the another term for vector addition is finding the resultant vector. Okay, when you are adding vectors means basically you are finding the single vector equivalent to those vectors. So therefore remember vector addition means equal to finding the resultant vector. Addition of vectors means resultant vector. Right, addition of vectors means resultant vector. Now look here, next page. Now I have given some laws. Okay, vector addition. Now right now vector addition we can consider when there are two vectors. Okay, now somewhere else write down vector addition means the resultant vector. Vector addition means resultant vector of those two vectors, so those many vectors. Right, vector addition, if not we can tell vector addition as resultant vector. So this is equal to, remember, equal to resultant vector. That is equal to resultant vector. That is equal to resultant vector. Resultant vector. Okay. Resultant vector. Okay. Now, if there are two vectors, when there are two vectors, we can use two different laws to find the vector addition, right? In exam, in a question, if there is only two vectors and if you want to find the resultant vector, you can use two different methods, right? Okay. If there is only two vectors, we can use a theory called a law called triangle law of vector addition, right? First method is triangle law, triangle triangle law. Second method is we are calling as parallelogram law. If there is two vectors, we can use two different laws to find the resultant to add those two vectors. One method is triangle law, other method is parallelogram law. Other method is parallelogram law. PARA, parallelogram law. Okay. Right. Now, what is triangle law? Now, triangle law, now read what is mentioned triangle law, the definition. Triangle law means, you can, when you read it, you understand. Triangle law means, now read that. If two vectors from consecutive sides of a triangle, the resultant is the third side of the triangle, which closes the triangle. Which closes the triangle. Now you just think for an example. Now there's an object, and there are two forces acting on the object. Two vectors, if not two forces, acting on the object. Just think one force is acting horizontally. One force acting horizontally, that is a horizontal force, right? So this is, let's say, 5 Newton to the horizontal. I name it as vector A. This vector is a horizontal vector. It's a force. Horizontal force is 5 Newton. I give a name for that vector simply. There is another vector acting on there is another force acting on the object. That is how much? That is, let's say 12 Newton. This is 5 Newton right side direction. This one is 12 Newton. Angle is 30 degrees something. If not, angle is theta. This is vector simple B. Okay. Vector A, vector B. Now look here. This idea. Now this idea. Now, if I tell this vector is 5 Newton, and the second vector is, let's say, in the same direction, second vector is 2 Newton. What is the resultant of these two vectors? If you add these two vectors, addition of these two vectors, if not resultant of these two vectors, means what? Resultant vector will be same direction 7. If there are two vectors in same direction, you can add their magnitude and you can obtain the resultant vector, right? But now in this case, this is vector addition, right? One vector is this one, second vector this one. You want to add those two vectors. When you add these two, same direction, 7 Newton. Just think, this vector is right side direction 5 Newton. You want to add this vector with 2 Newton vector left side direction. Earlier, both of them were in same direction. Therefore, when you add those two vectors, resultant is 7 Newton right side. But now can you write? Resultant vector is 7, 5, 2. As I want to add these two vectors, 5 plus 2 is 7. Can I write? We can't write, right? We can't write. Why? Because right side direction 5 Newton, but this one is left side direction 2 Newton. When you add these two, addition of these two vectors will be, right side direction 3 Newton. You understand the story? Addition of, now when you add these two vectors, resultant is 3 Newton. You know why? When direction is different, we can't add always. When direction is different, we can't add always to get the resultant. When direction is same, yes, we can add always to get the resultant. But when direction different, you can't add. In this case, you have to subtract. 5 minus 2, 3. vector addition, if not the resultant, 3 Newton. What will happen? Third case, you have 5 Newton force right side. You want to add 5 Newton with 2 Newton, angle is 30. How can you find the resultant? Can you tell the resultant? Can you tell the resultant is 7 Newton, right side? Can you tell the resultant is 7 Newton this direction? You can't say, right? Then now remember, when there are two vectors and when directions are different, in order to find the resultant only, we are using triangle law, parallelogram law, right? When directions are same, no need any laws, we can just add them to find the resultant. When directions are opposite, you can subtract and you can obtain the resultant. But remember, when directions are not either in same direction nor in opposite direction, if the directions are different, then you need triangle law or parallelogram law to get the resultant, if not get the addition. Now, triangle law says something like this. Triangle law says, now you know how to represent the vector graphically, right? So you should draw a length proportional to the magnitude of the vector, right? Arrowhead shows the direction of the vector, right? You know how to draw a vector graphically. Now, triangle law says that you draw vector A and vector B graphically. Draw vector A and vector B graphically. Start from whatever the vector that you like. If you like to start from vector A, you can start from vector A. If you like to start from vector B, you can start from vector B. Now, I like vector A, therefore start drawing vector A. Right? Vector A, I finished drawing. Magnitude proportional to the length. Direction, arrow. Then from the point where you finish drawing first vector. This is the point I finished drawing first vector. I started drawing vector is this point, is the initial point. I started from here. I finished drawing my first vector here. From the point where you finish drawing first vector, start drawing second vector. Start drawing second vector. Second vector using meter ruler, right? Using to a proper scale, start drawing second vector. And use your protractor and obtain this, measure these angles and mark it. Using the protractor and properly mark the angle. This angle is theta, right? This is the point where I finished drawing my second vector B. Initial point is here. I finished drawing second vector also at this point. This is the final point. Final point. Initial point, this one is final point. So then this law says that draw two vectors in same direction. Now see, direction of vector A and vector B is in same direction. So they look like moving in anticlockwise direction. They look like moving in anticlockwise direction, right? If you represent two vectors as two sides of a triangle, the third side represents the resultant vector. Initial point is here, final point is here. When you draw a line connecting initial and final point, this is the resultant vector. Am I correct? Right? If you measure the length and if you convert it to magnitude, you can obtain the R value. This angle is resultant vector angle. So this is what triangle law says. Got it? Right? This is what triangle law says. Now, parallelogram law. Parallelogram says now, if there are two vectors, you can use triangle law and you can find the result. If not, the parallelogram law says that if there are two vectors, vector A, vector B, now parallelogram law says that represent these two vectors in converging way. Represent these two vectors in diverging way. Represent these two vectors in diverging way. You know, converging means coming to one point. Diverging means you know that leaving from same point, leaving from one point. This is diverging, right? So then represent these two vectors in diverging way, right? If I draw it according to a proper scale, vector A, then vector B. See, from this point, these two vectors are diverging. Diverging way, I represent it. Then complete the parallelogram. Using these two vectors, complete the parallelogram. then you should draw parallel lengths. The length parallel to this one is this one. And parallel length. Complete the parallelogram. I complete the parallelogram. This point is point O something. Diverge, first step is diverging way represent the vector. Then draw the parallelogram. Draw the parallelogram. Then draw the what? Then draw the law says what? Law is saying what? Law is saying if two vectors are represented by two adjacent sides of a parallelogram, the diagonal, right? The diagonal drawn from their common starting point. This is common starting point, right? This is the point O. Common starting point, CSP, common starting point. The diagonal drawn from their common starting point to the opposite corner of the parallelogram. This point is the opposite corner, OC, opposite corner. When you draw the diagonal, of this parallelogram, this is the resultant vector. This angle is alpha, right? Triangle law says something like this. Parallelogram law says something like this. If you draw this graphically, and when you measure this length of the diagonal, length is proportional to magnitude. By using protractor, if you measure the angle, you can find this alpha, right? Now, but you know that now when we do MCQs, when we do questions, we can't draw everything graphically, and we can't measure the length, and we can't obtain the result. In MCQ essay questions. We can't draw length, and we can't draw length into a scale using meter ruler, and we can't use protractors to measure the angle, and we can't find result using graphically. It takes so much time. But therefore, what we do, we are using some equations. Some equations derived from these two concepts. Now look here, parallelogram law, triangle law. Look here. Now I can say, okay, now vector somehow, look here in this diagram, vector A means this is your vector A, this is your vector A, this is your vector B. Simply, right? Careful listen. Right, careful listen. Now 7:30. We have half an hour more. We can finish the theory. Questions also we want to do. Vector simple A. This is vector simple B. See, vector simple A and vector simple B. Right, represent, if you represent vector simple A and B in diverging manner from a point, angle between them is vector simple A, vector simple B, angle between them is theta. Always remember, now in here also you can do same thing, vector simple A, vector simple B, diverging manner. Quick revision, okay? Every chapter in the syllabus, we are doing a revision like this, right? Also, we are doing a paper class also every Saturday. See, vector simple A, vector simple B, diverging manner, angle is theta. Always remember, the resultant always passes in between vector simple A and vector simple B. Resultant always passes in between vector simple A and vector simple B. The resultant always passing through between vector simple A and vector simple B. This angle is alpha. Right? Okay, up to now, all the stories that we explained quickly, everything is very clear, hands up. All the stories, if you really understood, hands up. If you understood, hands up. Everything is very clear. Everything is very clear, hands up, if you understood. Right. Okay. Now what are we doing? Graphical methods we are not going to use in questions. So what we do now, next page in that PDF, please fill that enter. Now take a printout and fill all the important points that I explained in the class. It's a quick revision, right? Then we are parallel, we are doing questions also. I will take the plan, everything properly. So then look here, page number, I think page number 3, equation method. So summary is, if there are two vectors, vector simple A, vector simple B. Now you can find the resultant vector using equations. You can find the resultant vector using equations. Now I am erasing this one. Okay. Addition of vectors, resultant vector. You can obtain addition of vector, resultant vector in two different. Look here. Now the idea is, now there are two vectors. Vector simple A. If not, I say this, I name this vector as vector P. Vector P, this vector is vector simple Q. There are two vectors. Angle between these two vectors, theta. Theta measuring decrease or something. Then I told you resultant will be passing in between those two vectors. Resultant will be passing between those two vectors. Resultant vector is capital R. This angle is alpha. In exam, if you want to find capital R, there are different methods. Okay. The method one is case one. Now, when you see method one, now you can use method one like this. The method one is, there are two vectors, you want to find the resultant. But method one, if not case one, you can use when the magnitudes are different. Now, two vectors, 5 Newton, 2 Newton. If two velocities, 10 m is minus 1, 15 m is minus 1. Magnitudes are different. When you see different magnitude different, then angle between them is not 90. Okay. Whenever you see two vectors with different magnitudes, and if the angle between them is not 90, that means 60 degrees, 70, 80, 85, 30, 40. If the angle is not 90, then you can apply below equation. Right? Then you can apply, you must learn by heart. In order to find the resultant, vector, you can use this equation. R squared equals P squared plus Q squared. That means magnitude of P. This P means magnitude of P. Q means magnitude of Q vector plus 2PQ cos theta. Right? Learn by heart. You must learn by heart this equation. Right? In revision class, we don't teach how this equation is derived. We can't teach. Then it will become a theory class. Can't finish within 2 hour, 1.5 hour revision. Then angle. This angle alpha, remember. This angle alpha, tan alpha means, remember, tan alpha means, okay. This inclined vector is Q. Horizontal one is P. Q, start from Q. Right, start from Q. Q sine theta over Q sine theta over P plus P plus Q cos theta. P plus Q cos theta. This is the angle equation. Right? Learn by these two. But again, if there are two vectors, right? Again, if there are to look at it, again, if there are two vectors, but this time what happens? Case number 2, again, there are two vectors with different magnitudes, 5 Newton, 10 Newton. But magnitude is different, but angle between those two vectors is 90. Whenever you see, angle between those two is 90. Magnitude is magnitude different, But when you see angle between those two vectors is 90, then you can apply. That means something like this. That means something like this. Vector P will be horizontal and angle between P and Q vector is 90 means vector Q will be like this. Am I correct? Vector Q, vector P. Then the resultant is vector R. Resultant is vector R. Resultant vector R. Remember, you can find the capital R magnitude using capital R means, remember, capital R means equal to root P squared plus Q squared. So you know why? You know why? Because when the angle is 90, when theta is 90, cos 90 means 0. Cos 90 0 means 2pq cos theta term becomes 0. Then only remains r squared equals p squared plus q squared. When you substitute r means root p squared plus q squared. Learn by heart. If the magnitudes are different and angle is 90, then how do you find this angle alpha? Alpha? Tan alpha means, remember, tan alpha means opposite. What is opposite? Remove this q vector and paste here. Remove this q vector and paste here. Then it creates a right angle triangle. Opposite is q, adjacent is p, q over p. Second one. Okay. There is another method. If there are two vectors, case number 3. If there are two vectors, in case number 3, magnitudes are same. Now, case 1, case 2, magnitudes different. Angle is not 90. Here, angle is 90. But in case number 3, two vectors, magnitude same. Right? If two vectors, 5 Newton, 5 Newton. 16 ms minus 1, 16 ms minus 1. If two vectors, magnitude same, then you know that what? You know what? That means something like this. Vector P, this is also vector P. Angle between them is theta. Resultant will be, remember, resultant is passing through the middle. That means resultant will be the angle bisector of these two vectors. Resultant will be the angle bisector of these two vectors. If the angle between these two vectors is theta, then tell me what is your alpha. If the resultant is the angle bisector, that means this resultant divides theta equally. Your alpha is what? Your alpha means theta over 2. Right? This angle also theta over 2, theta over 2. Theta over 2, theta over 2. In this case, magnitude same means resultant will be, remember, 2p. Resultant will be 2p cos theta over 2. Resultant will be 2p cos theta over 2. Right? P means magnitude of one vector. Theta means angle between those two vectors over 2. Right? Alpha means theta over 2. Angle is half of the theta. Right? See? Now, from this knowledge, we can do some questions. Okay, there's one more part only. That is easy. Okay. Quickly. I will give some minutes. We'll take 5 minutes and we'll revise everything quickly. What we now, this knowledge quickly. We start around I think 6:30. Now time is 7:30. 1 hour. A quick revision. If all the important points should be known by a student, I think I revise everything quickly. Now one last part is there in vectors, and then we'll do some questions. Then we can finish today's session. Right? But in paper, we'll put some good standard questions, and we are discussing more. Kind of quick revision. We can't revise everything, detailing, explaining, deriving the equations. We can't do such a revision. We can't do. But this is possible. But this is very effective if you are following from beginning to end. Every week we are having night classes. Recordings I will provide separately. If you miss also, you can watch them. Yes, I will give 5 minutes. Time is now 7:38. 7:43. I will start. Right. Raise your hands. Whatever we learn now, I think we discussed how to find the addition of two vectors in graphical method and in equation method. Graphical method, triangle law and parallelogram law. Equation method, in case 1, case 2, case 3, you should remember these equations. This is kind of short note revision, right? But I didn't teach you anything about if there are more than two vectors acting on a system. Let's say if there are five vectors acting on a system, how to find the resultant graphically, how to find the resultant following some calculation. I won't teach you that. So far, everything is very clear. Quick revision. So far, everything is very clear. Hands up. If you understood everything very clear, hands up. So quick revision, right? You can't explain, you can't expect something deep, can't do that, okay? Right? But we are revising. If you want to learn something deep, then definitely you should join for a theory class. Right? In theory class, you know that how many hours I take and I teach. But if you cover these roughly, if you forget these theories, this revision is very beneficial. Right? We are writing papers every week. We are writing papers. Now, tolerate for this month. I could not send the tudes PDF for revision people earlier, but February onwards, we'll plan very nicely and I will send tudes twice in a week. Sorry, tudes once in 2 weeks. Okay. Right. The last thing, when there are more than two vectors. Earlier, when there are only two vectors, now if there are more than two vectors, how to find the resultant? Listen. Now, more than two vectors. Graphical method is if there is more than two vectors, graphical method is more than two vectors, on three vectors or 4, 5, 6 or whatever. Graphical method is, remember, graphical method is polygon law. Right? Graphical method is polygon law. Polygon law is something similar to triangle law. Triangle law, there are two vectors. In polygon law, there are many vectors. Polygon law. What is this polygon law? I will brief very quickly. It's very easy things, very simple ideas. Now, just think. Give me a second. Now, just think. There are four. Now, there's an object. There's an object. There are four vectors acting on this object. Right? There are four vectors acting on the object. Vector A. This is vector A. And then this is vector B. This angle, let's say theta. This angle, let's say theta. Next one is vector C. Last one is vector D. Last one is vector D. This angle is gamma. Now think, there are four vectors acting on this object. I want to find the resultant vector. If not, I want to obtain the addition of these four vectors. I can't add like this, A plus B plus C plus D. That is a resultant vector. I can't do that because these are vectors. Then how can I find the resultant of these four vectors? One method is polygon law. That is a graphical method. Polygon law is a graphical method. How can I find? Polygon law is a graphical method if I explain the graphical method. Right? What polygon law says simply, the polygon law says something like that. Like how we define triangle law. Start from one of your favorite vector. I'll start from vector A. Is vector A. Graphical represent vector A. You should draw a length proportional to the magnitude using a proper scale. measuring angle using protractors or anything. Then from the point where you finish drawing first vector, start drawing the second vector. So simple B is my second vector. So you can select simple vector C as your second vector. If not, you can select vector D as your second vector. It's up to you. I take vector B as my second vector. Using the protractor, I measure this angle, everything properly. Using the meter ruler, I draw this line segment according to proper scale. Then vector C. Then vector C. And from the point where I finish drawing vector C, should draw vector D. Should draw vector D. I started drawing vector A. I started drawing this vector system from this point, my initial point. I finished drawing these four vectors, 1, 2, 3, 4. These four vectors, 1, 2, 3, 4. I finished from this point, finish point. When you connect a straight line, when you connect initial and final point by straight line, initial to final, always remember initial to final, that should result in. Initial to final, that should result in. Very similar to triangle law. Triangle law, there are only two lines, there are only two vectors. But in polygon law, there are many vectors. Then how to find a resultant using graphical method. But you know that in exam, can we use polygon law and can we find the resultant? No, right? We can't do that, because if there are more than two vectors, you want to measure into proper scale and you want to measure the angles, and how can you do that with quickly? Right? You can't do that, right? You can't do that, right? This angle gamma, right? So this angle gamma means this is your vector D. This angle also gamma. This angle gamma is this angle gamma. So this angle is gamma. Okay. So now, so therefore, what we do, if there are many vectors acting on a system, how to find the result? That is the important one. That is the last theory. Then everything revised. All the important points revised. Polygon law, we know we understood, but we can't apply for questions because it takes time. So then, when there are more than two vectors, how to find the resultant? First, for an example, look here. The calculation method. I'm erasing this. The calculation method. Graphical method is one. Second one is calculation method, different equation method. Equation method. Equation method C. Now they have given four vectors. Let's say P1, P2, P3, P4. They have given four vectors. They have given four vectors. This vector, let's say P1. Right, within 1.5 hours, I think I revised everything. This vector is vector P1. This angle adjusting theta 1. And the second vector is, this vector is vector P2. This vector is P2 vector. This angle, take it as theta 2. This vector is vector P3. Angle is theta 3. This vector is vector P4. This angle is theta 4. This angle is theta 4. The first method is resolve. Vector resolution. You know what is vector resolution? We learned today. Vector resolution means given vector, we are dividing into two perpendicular components. So first of all, the first step is, now what's your goal? There are four vectors. I want to find the resultant of these four vectors. If not, I want to find the addition of these four vectors. Step one is vector resolution. Right? Resolve all the vectors into two perpendicular components, vertical and horizontal directions. Step one, resolution. Step one, resolution. Now, if you resolve vector P1 into two perpendicular directions, look here. Vector P1 into two perpendicular directions, horizontal one will be what? Horizontal one touches the angle. P1 cos theta 1. What is the vertical component? P1 sin theta 1. Am I correct? Likewise, resolve P2, P3, P4. If I resolve vector P2, horizontal component will be P2 cos theta 2. Vertical component will be P2 sin theta 2. P2 sin theta 2. If you resolve P3 into two perpendicular directions, horizontal component will be P3 cos theta 3. Vertical component will be P3 sin theta 3. If you resolve vector P4, two perpendicular components, P4 cos theta for horizontal component, P4 sin theta for vertical component. This is a summary, okay? It's a revision, right? If you are very new and if the very first time, if you are learning this, you might think it's complex, but now we are revising, okay? Theory class, we take time slowly we are teaching. But revision means I'm revising them. Okay. First step is resolve. Yes, so you resolved. If I draw that, if I draw, you resolve the vectors into two perpendicular directions. Okay. You resolved all the vectors into horizontal and vertical directions. First step is done. Okay, P1 cos theta 1. Ni P1 cos theta 1. P1 sin theta 1. P2 cos theta 2. P2 sin theta 2. P3 cos theta 3. P3 sin theta 3. P4 sin theta 4. P4 cos theta 4. Resolution. Done. After resolving the vectors, second step is what? The second step will be, after resolving them, the second step will be what? Second step is obtain vector sum in x and y direction. Right? You want to obtain vector sum in x and y directions. Step 2, remember, step 2, vector sum in x direction and y direction. Now tell me, in the x direction, horizontal direction, how many vector components? 1, 2, 3, 4. In y direction, in vertical direction, how many vector components? 1, 2, 3, 4. Right? So when you find the resultant vector component, resultant vector in x direction, that is equal to what? Right side direction P1 cos theta 1, P4 cos theta 4 also right side direction, therefore plus. These two right side, therefore plus. P2 cos theta, sorry, P4 cos theta 4 minus this P2 cos theta 2 left side, P3 cos theta 3 left side. Therefore, minus P2 cos theta 2 minus P3 cos theta 3. So this is the resultant vector in x direction. Then how do we find the resultant vector in y direction? Upward vectors plus P1 sin theta 1 upwards, P2 sin theta 2 upwards. Then we can write down P1 sin theta 1 plus P2 sin theta 2 minus P3 sin theta 3, P4 sin theta 4 downwards. P3 sin theta 3 minus P4 sin theta 4 downwards. So what have you done? See, what have you done? See, actually in the beginning there was 4 vectors. If using the resolution, you converted them again to 8 vectors. 1, 2, 3, 4, 5, 6, 7, 8. After finding resultant vector in x and y direction, again you converted them into two vectors, right? Now this system is equal to 2 vectors. What? X, this is vector x, this is vector y. 4 vectors, resolution became 8 vectors. Again, after finding resultant in xy direction, you brought to 2 vectors. Now you know there are 2 vectors x and y, angle is 90. Then you know the equation, right? I told you case 1, case 2, when there are two vectors, equation method, case 1, case 2, case 3. If there are two vectors, different magnitude, angle 90 means what is the equation for the resultant? The equation for the resultant is how much? R equals root capital X squared plus capital Y squared. Angle alpha, tan alpha means what? Tan alpha means opposite is Y, adjacent is X. This is the entire theory of vectors. Finished. Theory wise, everything is finished. I took 1.5 hours and I finished. This is the entire theory of vectors. Entire theory of vectors. Okay. All right. Hands up. Now we'll do few questions. Don't worry, we'll do few questions. 8 o'clock. We should start at we should have started around 8 o'clock, but we could not. Okay, fine. Raise your hands. Vectors revision. Now I'm not going to teach vector revision again, but when you do vector questions in papers, definitely we discuss. But as a revision, vectors revision this much. If you can remember these things fully enough, and when you practice different types of vector questions fully enough for the L exam, whatever we learned in this vector revision, if you really understood, raise your hands. Raise your hands. If you understood, raise your hands. Everything very clear, raise your hands. Raise your hands. Okay. Then revision is finished, but we'll do some questions to practice. We'll discuss few questions, and we are having a paper in this Saturday. In that paper, you should be able to try the questions. Okay. Now, in that PDF, I have given set of questions. We'll discuss few. Right. Now, question discussion 1. Considering the following statements about scalars and vectors. Scalars and vectors, you know, scalars and vectors. They have given 3 statements. Now, question 1. Now, consider the following statements about scalars and vectors. Statement A. Scalar only has magnitude. Correct me? Scalars only having magnitude. Correct. B. Vector has a magnitude and direction. Yes, correct. Vector has magnitude and direction. Correct. Multiplying of a vector by a scalar always gives a vector. Right? When you multiply a vector by a scalar, 5 or 6 or 7, when you multiply a vector by a scalar, the result is always a vector. It's correct. A, B, C, all are correct. Right statement, this question is correct. You understand, right? From today's knowledge, what you learn, you can say the right answer for question number 1 is 5th one. Right answer will be 5. So then we'll do question number 2. Which of the following physical quantities represent a pair of vector? Sometimes you are not able to do this question because why? Still, just now revision started. If you don't have previous knowledge, sometimes you are not able to answer these questions. But in the revision, we learn about pressure, we learn about displacement, time, force, temperature. So therefore, before you go to the exam, you are able to do this question also. Which of the following physical quantities represent a pair of vectors? Now, speed, displacement. Speed means scalar, displacement vector, not pair of vectors. Weight, acceleration. Weight is a force is a vector, acceleration is a vector. Therefore, right answer is second one. Question number 2, answer will be second one. Third one, which of the following physical quantity is a vector? Energy, speed, pressure, angular momentum. Right? Answer is third one. Answer is fourth one. Angular momentum is a vector, but you don't know what is angular momentum. You will learn in rotational motion revision. Angular momentum is a vector. Answer is fourth one. Third one, answer is fourth one. Okay. Now, then fourth one, which of the following physical quantities is a scalar? Following physical quantities is a scalar. Density is a scalar. Acceleration vector. Pressure scalar. 26 students also know. Pressure scalar, I taught you, right? Energy is a scalar. So therefore, density scalar, pressure scalar. 26 students also know density and pressure are scalar, you know, right? Then ACD are scalars. A, C, D are scalars. Right answer is fifth one. Fourth one, right answer is 5. Fourth one, right answer is 5. See, from today's knowledge, what you can do. Fifth one, for two homogeneous vectors to be equal. For two homogeneous vectors to be equal, capital A statement. Capital A statement. For two homogeneous vectors to be equal, capital A statement, magnitude of two vectors must be equal. Yes. Now, two homogeneous vectors means, let's say, if two velocities, now their magnitude must be definitely same to be equal. If this velocity is 5, this also should be 5. Then only they can become equal. Statement A correct. For two homogeneous vectors to be equal, the magnitude of two vectors must be equal. That's correct. The two vectors should be represented by two straight line segments parallel to each other. Now, statement B will keep statement C. Statement C, the direction of two vectors must be equal. C statement also correct. The two vectors should be represented by two straight line segments parallel to each other. I told you, if there are two vectors to be equal, homogeneous, direction same, magnitude same. Therefore, B also same. Therefore, right answer is 5, fifth one. Right answer 5. Right answer 5. Right answer 5. Right. Next one, sixth one. Sixth one. Sixth one. Right. As shown in the figure, a toy cart inclined at 30 degree from the horizontal is pulled with the help of string. Tension in the string is 200. What force affects the motion of the cart? What is the vertical force acting on the cart? Look here. Now, not difficult, these things. These things are not difficult. Right? Now, look here. Question number 6. Question number 6. Now, tension force given is as how much? 200 Newton. Angle is given as how much? Angle is given as 30. Actually, no. Now, actually, which force contributes for the motion? Horizontal component of 200 Newton contributes for the motion. So basically, they are asking you that question. They are asking you to find the horizontal force component and vertical force component. Horizontal force component, how do you find? And vertical force component, how do you find? Horizontal force, let's say x, vertical, let's say y. X means what? X means the horizontal component touches the angle. So therefore, remember x means what? 200 cos 30. You know x means 200 cos 30. Am I correct? See, 200 cos 30. That means 200 cos 30 means root 3 over 2. That means you know x means 100 root 3 Newton. X means 100 root 3 Newton. Vertical component y, then y means 200 sine 30. X is 200 cos 30. Y means 200 sine 30. 200 sine 30 means half. That means 100 Newton is your y. Y. Question number 6 also done. Then question number 7. Now see, look here. 7 is a good question. 7 is a good question. 7 is a good question. Now seventh one. Seventh one. Now we are finishing now. I want to finish at 8 o'clock, but okay. 7 is a good question. The magnitude. Okay, now we'll finish the story. Okay. 7. Magnitude and direction of four forces acting on an object are represented in the figure by OA, AB, BC, CD, the resultant force. Now they have given 4 vectors. If I draw it quickly, question number 7, not difficult. Now from today's class, you can revise all the vectors theory. Now, seventh one, if I draw the diagram, see, something like this, something like this. Now, the vectors, this is O, AB, OA, this is B, this is C, this is D. Arrows, there are 4 vectors, right? This vector is vector P, this vector is vector phi P, right? This vector is vector phi P, this vector is how much vector 10P, magnitudes, 10, this 10P means magnitude, phi P means magnitude, P means magnitude. Again, this is phi P. Now, there are how many vectors acting in the system? There are 4 vectors. 1, 2, 3, 4. I told you when there are 4 vectors, now that means if you want to find the resultant vector, you can use polygon law. If not, you can use calculation. But better if you use polygon law for the story. You know, polygon law means 4 vectors represent in one direction. See how the way they represent first vector. OA vector, from the point where they finish OA vector, they start drawing second vector, AB. From the point where they finish drawing second vector, they start drawing third vector. From the point where they finish drawing third vector, start drawing fourth vector. Initial point is here, final point is here. Then what is your resultant? Resultant of those 4 vectors will be this one. OD is the resultant. Am I correct? OD is the resultant. The resultant will be OD, that means phi P. OD, that means phi P. Magnitude phi P, direction OD, that means upwards. Upwards. See, answer is OD phi P, first one. Seventh one, answer is first one. So we'll go to question number 8. Eighth one, 6 coplanar vectors AB, BC, DC, ED, EF, FA represents in the figure. Resultant of these 6 vectors. There are 6 vectors. If I do that question, see, very easy. From today's theory, all of you can understand. Right? If I draw now these 6 vectors, something like this, something like this, something like this. Look here. Now this is A, this point is B, this point C, this point D, this point E, this point F. There are 6 vectors acting on the system. What are those? Look here. What are those? Now EF vector, see, EF vector upward, FA vector right side, AB vector downwards, AB vector downwards, then BC this direction. Okay. Then 1, 2, 3, 4 vectors. EF, FA, AB, BC, 4 vectors. Fifth vector is, look here, ED vector. Fifth vector is ED. I use different color for a reason. Fifth vector is ED. Sixth vector is CD. Now look blue color vectors. Look blue color vectors. When you look blue color vectors, right? Starting point is E. Starting point is E. Starting point. Then polygon law. First vector finishes here. From the point where first vector finished, start drawing second vector. Arrows must be in same way. Arrows must be flowing in same way. Second vector. From the point where second vector finished, start drawing third vector AB. From the point where finish drawing third vector, start drawing fourth vector BC. Right? But I can't consider CD because arrow is different. Arrow is flowing opposite. So, but when you consider EF, FA, AB, BC, let's say this is C is the finishing point. C is the finishing point. Starting point is E. C is the finishing point. Then what is the resultant of EF, FA, AB, BC? The resultant of blue color 4 vectors will be initial to final EC vector. Am I correct? Resultant of these 4 vectors will be EC vector. EC vector. Up to now, hands up. Everything is very clear. Hands up. Resultant of these four blue color vectors is easy answer. Resultant of those four blue color vectors is easy answer. Is easy. Right. Now, therefore, I'm erasing those four. Now, instead of those four vectors only, we used that red color easy. So I'll erase those four vectors. Okay. I erase those four vectors. I'm erasing. Then look at this ED and AC. What is the resultant of now? Starting point E, finishing point F, ED, DC. The resultant of these two vectors also again is EF. The resultant of these two vectors also again EF. What is the total resultant? EF, EF means 2 EF resultant. 2 EF resultant. 2 EF resultant. See, 2 EF resultant. Answer is 2 EF. Sorry, 2 EC. Yeah? This is C. This is final point. Okay, EC. 2 EC resultant. 2 EC resultant. Okay. Now then, so then look here. Then question number 9. Question number 9 also. Okay. Question number 9. Quickly, we'll go to 9th one. We'll stop at 8:30. Now 9th one. 9th one you can do. Now we'll come to 10th one. We'll come to 10th one. Two forces, 3 Newton, 4 Newton, act perpendicularly on an object. The vector diagram that accurately gives the magnitude and direction of the resultant of those two vectors. Triangle law. Triangle law, right? Triangle, what is the right one? Now I told you now there are two vectors. Question number 10th one, there are two vectors. One is 3 Newton. Other one is 4 Newton. Perpendicular. If you represent triangle law, you can start from any vector. Let's say we are starting from 3 Newton. We are starting from 3 Newton. From the point where you finish drawing 3 Newton, should do the second vector. Should do the second vector. Then you should do the second vector how? Okay. Like this. Like this. Okay. Then initial point is here. Final point is here. Resultant will be, look here, initial point is here. Final point is here. Resultant will be initial to final. Right. You should get a right angle like this. But when you see, there is no diagram like this, right? But then what you can do, you can start from 4 Newton. Start from 4 Newton. Triangle law started from 4 Newton. From the point where you finish drawing 4 Newton, you are drawing your second vector. You are drawing your second vector. 3 Newton. Initial point is here. Final point is here. Start drawing 4 Newton. Then 3 Newton in the same direction. Initial point is here. Final point is here. Connect initial final point. When you connect initial final point, that is the resultant. So the right diagram is fourth one. Fourth one is the right diagram. 4 Newton, 3 Newton. Answer is fourth one. Fourth one. 11th one. Which of the following figure correctly represent the two vectors P and Q and their addition? Their addition means resultant. Resultant, right? Their addition means resultant. Parallelogram law. Parallelogram law, I told you, look here. Parallelogram law means vector P, diverging manner, vector Q. Diverging manner, vector Q. Okay? Complete the parallelogram. Complete the parallelogram. Diagonal, diagonal. Diagonal, but arrow must be from common point to opposite point. This is the common point. This is the opposite point. The diagonal must be from common to opposite arrow. What is the right one? Right one will be, I think, third one. Right one is third one. Question number 12. 12. 12. Question 12. The resultant of two vectors acting at an angle 60 is 2 root 3. If one of the vector is 2, what is the magnitude of other vector? The two vectors calculation equation method. If there are two vectors, how to find the resultant using equation method? Case 1, case 2, case 3, we learned. Right? Now there are two vectors. There are two vectors. Magnitude of one vector is 2. Other one magnitude, actually, I don't know. Other one magnitude, I don't know. I take it as Q. I want to find Q only. Angle, if two vectors acting at an angle 60. Angle between them is 60. Theta is 60. We know resultant will be in between 2 and Q. This is the resultant vector capital R. Resultant vector is given as 2 root 3. Resultant vector given as 2 root 3. 2 root 3. See? Now, two vector cases. Case 1, case 2, case 3. Case 1, I told you, angle is not 90 and magnitudes are not same. Then, what is the equation to find the resultant vector? R squared equals P square plus Q square plus 2PQ cos theta. Learn by heart this equation. R is 2 root 3. 2 root 3 whole squared plus your P means how much? P means 2. P means 2. 2 squared. But you want to find Q only. Q squared 2. P means 2. Q cos how much? Cos 60. Cos 60. Now separately give the square for both. Now 2 square means 4. 4 into 3. Here 4 plus Q squared. 4Q cos 60 means half. Cos 60 means half, right? Cos 60 means half. Okay. Now then simplify. Simplify. Right, when you simplify, you get the answer. Right? When you simplify, you get the answer. Okay. Now your target is finding Q, quadratic equation. You are getting a quadratic equation. Right? So now 12, here it's 12 equals 4 plus Q squared. 4Q into half means 2Q. So Q squared, now Q squared plus 2Q. Somehow when you simplify, minus 8 equals 0. You simplify this quadratic equation, you get the answer. How many of you can follow? How many of you can get this hands up? How many of you can obtain the Q value hands up? How many of you can obtain the Q value hands up? Right? What you do, you try at home. Next one. We'll do next question. We'll do next question. Next one. 13. Resultant of two given force is perpendicular to resultant of two given force is perpendicular to root 3 Newton force. Okay. The angle between the resultant and the 2 Newton force. Okay, we'll go to 14. You can try 13 also. We'll do 14 also with the 14. Now 14, magnitude of the resultant, 14. Magnitude of the resultant when two forces 2 Newton to root 2 Newton act obliquely angle 45. There are two vectors again. 2 Newton. This one is root 2 Newton. Angle is how much? 60. Angle is 45. Angle 45. You want to find the result. Again, same equation. Again, same equation. R squared equals P squared plus Q squared plus 2PQ cos theta. Now you want to find capital R. You want to find capital R. Capital R square means P. P means 2. 2 square means 4. Q means what? Q means root 2. Root 2 square means 2. Plus 2. P means 2. Q means root 2. Cos 45 means how much? Cos 45 means 1 over root 2. Root 2 cancel out. Then 4 plus 2. 4 plus 2. 2 into 2 means 4. Again 10. R squared means 10. R means root 10. R means root 10. Right answer is fourth one. Right answer fourth one. Right answer fourth one. 15. 15, look here, 15. What must be the angle between vectors for the resultant of two vectors of equal magnitude? What must be the angle between the vectors for the resultant of two vectors of equal magnitude to be equal to magnitude of that vector? Okay, this is something good question. Look at the 15th one. Now theory wise finished. We are doing few questions, right? But we will do very nice questions in the next day, upcoming days. Okay, I will have a nice plan also. Oh, next one, right now. Next one, see. Next one. 8:30. Next one, you see. Let's say now there are two vectors. I say this vector is vector P. Now these two vectors are equal in magnitude. And the angle between them is theta. They are telling result in order to resultant also to be equal to P. Now they are telling two vectors are there, their magnitudes P, P. They are telling resultant also becomes with a magnitude P. This happens at what theta angle? Right now, there are two vectors magnitude P, P. In order to obtain resultant also P value, what should be the theta? I told you when vectors having equal magnitude means when two vectors equal magnitude means resultant equals what? R equals 2p cos theta over 2. See, from what I taught you today, you can do all the questions. You can try all the past papers. Just try and see. Then R also P, 2p cos theta over 2. PP cancel out. This 2 comes to here means half. Half means cos theta over 2. Half means what? Cos 60. Half means cos 60 equals cos theta over 2. You know that cos cancel out. 60 equals theta over 2. Theta means 120. Theta means 120. See? Go home and do it. Then 16. 16 also easy. 16? 16 easy. 16. I do. You know that theory class I don't do like this. But revision we want to quickly do it. Now the angle between two vectors P of magnitude simple P each is theta. They are asking us to the resultant. They are asking the resultant, right? Now when there are two vectors, see question number 16, look here. 16, when there are two resultant vectors, this is also P, this is also P. If the angle is theta, what is your resultant? Resultant is what? That equation, 2P cos theta over 2. 2P cos theta over 2. 2P cos theta over 2. Fourth one is the answer. Then the last one. The last one I will stop doing from question number 18. Okay, I'll stop doing, I finishing the revision session vectors from question number 18. 18. Magnitude of x and y components following force system are shown respectively. Right, now look here, the last question for the vector revision. Last question of the vector revision. Today what I want is I want some feedback from you, especially 25 if you are planning to join for revision. From the 25 students, how about the revision, whether it's effective or not? And also 26 students also, if you can put a small response, that's really better, right? Expecting that response from you. Okay, the last question for the day. The last question for the day. The last question for the day. Okay. Resolution. Now, if I draw that vector system, how many forces? XY directions are there. XY directions. One force 30. Other one 10. This angle is 45. There is vertical force also 20. This is 30. This is 10. This is 10. This is 40. How many forces, how many vectors are there? 1, 2, 3, 4, 5, 6, 7. There are 7 vectors. 1, 2, 3, 4, 5, 6, 7. There are 7 vectors. 1, 2, 3, 4, 5, 6, 7. Now they are asking you to find the resultant vector in x direction, resultant vector in y direction. Last theory part. So then you want to resolve 10 into 2 components. When you resolve 10 into 2 components, what is the horizontal component? Horizontal one will be 10 cos 45. Vertical component 10 sin 45. Am I correct? Then this one. Because can you resolve the horizontal vector to horizontal and vertical components? We can't. Already it's in horizontal. This 20 already it's in vertical. This 10 already horizontal. This 10 already vertical. Then you want to resolve this one. Now this angle is given as 60. This is 60. Then what you can do? This component, this vertical component will be 30 cos 60. 30 cos 60. This component will be 30 sine 60. 30 sine 60. This one, this angle is given as 60 again. Then if you resolve this 40 into two components, horizontal component will be 40 cos 60. Vertical one will be 40 sine 60. Then can't you find x? How many horizontal components? 1, 2, 3. 1, 2, 3, 4, only 5. Only 5. So 30 plus 10 cos 45 plus 40 cos 60 minus 10 minus 30 sine 60. Am I correct? What is the vertical one? Vertical one, how many vertical components? 10 sine 45, 20, 30 cos 60, then 10, 40 sine 60. Right? Then y means 20, 10 sine 45, 30 cos 60 minus these three done. Then minus 10 minus 40 sine 60 minus 40 sine 60 finally finished. A full revision. We'll do standard questions in that paper class. Right? And there are separate sessions to complete past paper questions also. Everything is finished now. 8:30 exactly took 2 hours, but completed vectors fully. 2 hours, completed vectors fully. Now, how many of you failed today's session? Effective hands up. Effective. If you failed today's session, is effective hands up. Okay. So now today we'll stop. Now 25 revision. Now, as I told you, now night time better we do some revision classes. Now that's why I thought of do the class at night. Then 9 to 11, 11:30 we can do. So now covering one day, I take 2 hours and covering one section, vectors, then forces, the Newton laws. Likewise, we are revising all the sections, all the important points like this, all the important points. And every week we are having a paper. Then you write the paper. I give some time you to write the paper. Then we mark and we give. So likewise, but always this paper is prepared from the sections that we learned in the revision class. So then after 2-3 months later, now you are writing some good standard papers, because you need 2, you need 3, you need 4. Almost we can cover within 3-4 months. So therefore, it's a very big plan. With your support only, we can go this plan. Yeah, if not, if the students, if there are students only, we can do this big effort, and we can do something big. So right, okay. So then, anyways, we'll stop the class for today. Then we'll meet on. I will give I will share the message and everything in the group. Then you can get the idea. So we'll stop for now. Okay. Then see you. Have fun.